Hi, I'm ANguyen and my project's on endothermic versus exothermic. First, we're going to be talking about the definition. So the definition of endothermic is when heat is being consumed or going into a reaction. And for exothermic, it's when heat is being released or leaving a reaction. Some basic equations that you should know to find out if it's endothermic or exothermic is that if heat, for example, A plus B plus heat yields C is endothermic because heat is on the reaction side. And A plus B yields C plus heat is exothermic because heat is on the product side. So for example, melting. This is endothermic because ice, when it goes into a liquid, has to absorb heat, which means that delta H is going to be positive, which is why it's endothermic. Some more example of endothermic is when sublimation happens, and sublimation is when a solid turns into a gas. One more example is when vaporization happens. It's when liquid turns into a gas. And now an example for exothermic is freezing. When a liquid goes to a solid, they are releasing the heat, which is why the delta H is negative, and that's why it's exothermic. Some more examples: deposition. It's when a gas goes into a solid. And another example is condensation. And condensation is when a gas goes into a liquid. And how this all relates to enthalpy, or also known as delta H, is that if that delta H is greater than 0, you would know that it's endothermic. And if that delta H is less than 0, it's exothermic. Or you can also think of it as if delta H is positive, it's going to be endothermic. If delta H is negative, it's going to be exothermic. So as you see, this slide has graphs. Let's just look at this endothermic graph. You can see that the potential energy for the reactant side is lower compared to the product side. And to find out if this graph is going to show an endothermic or an exothermic, you would have to do the potential energy of the product minus the potential energy of the reactant. And since the product is higher than the reactant, the answer you would get is greater than 0, which is why it's endothermic. And if you look at this exothermic graph, the potential energy of the reactant is higher than the product, but you would still have to use the product minus the reactant to find out the delta H. And in this graph, since this product is lower than the reactant, you would get a negative number, and that's why it's exothermic. And how to use delta H in the equation. So you can see that this delta H is given, and it's 62.4 kilojoules. And since it's positive, it would have to go on the reactant side. And that's why it's endothermic as well. So as you can see, this delta H is negative 471.66 kilojoules. And since it's negative, it's less than 0, so you have to put it on the product side, and that's why it's plus 471.66 kilojoules. Thank you for watching, and I hope you guys know what's the difference between endothermic versus exothermic. Thank you.